What specific problem does the new method aim to solve in the context of LLMs and advertising?
The new method aims to solve the problem of efficiently allocating online ads within the output of large language models, LLMs, in the context of advertising. Specifically, the method addresses the challenge of integrating ads into the generated content of LLMs in a way that maximizes social welfare, ensures individual rationality, and maintains high output quality. By developing segment auctions that allocate ads for each discourse segment of the LLM output, the method aims to optimize the allocation of ads while considering factors such as relevance, user satisfaction, and revenue generation. The goal is to provide a framework that leverages the Retrieval Augmented Generation (RAG) technique to incorporate ads seamlessly into the LLM output, enhancing the user experience and potentially reducing the operational costs of running advanced LLM models. Ultimately, the method aims to explore how advertising can support LLMs economically and how different auction designs can influence the output quality and revenue generation in the context of online advertising within LLMs.
How does the proposed segment auction mechanism work for ad allocation in the LLM output generation process? Illustrate step by step.
The proposed segment auction mechanism for ad allocation in the LLM output generation process works as follows. 1. Segment definition. The auction divides the LLM output into segments, which can be sentences, paragraphs, or the entire document. 2. Ad retrieval. Relevant ads and their bids are retrieved from a database based on a user query. 3. Auction process. The auction receives these bids and click probabilities, aligning with retrieval probabilities, and implements a randomized allocation rule based on the RAG framework. 4. Single ad allocation. Initially, the auction allocates a single ad per segment. The RAG-based allocation rule is optimized with respect to a new notion of logarithmic social welfare, balancing economic efficiency and fairness. 5. Randomization. The randomized RAG allocation rule is obtained as a randomization over deterministic truthful auctions, ensuring truthful implementation of ad allocation. 6. Payment rules. The expected payment under this scheme matches the pricing rule derived from Meyerson's lemma. 7. Multi-ad allocation. The mechanism later extends to multiple ads per segment, perturbing bids with random additive offsets to accommodate multi-ad allocation. 8. Theoretical analysis. The segment auction is proven to be dominant strategy incentive compatible, DSIC, and individually rational, ensuring truth-telling and no participant being worse off by participating. 9. Multi-allocation segment auction. This version allows for allocating multiple ads in a single segment, optimizing the allocation and payment functions to achieve desired properties. 10. Output quality. The multi-allocation segment auction demonstrates higher output quality by allowing the LLM to optimize over the entire document, resulting in more coherent and relevant ad integrations compared to single allocation auctions. In summary, the segment auction mechanism efficiently integrates ads into LLM outputs by dividing the content into segments, retrieving relevant ads, running auctions based on RAG framework, and optimizing allocation for both single and multiple ads per segment to enhance revenue and output quality.
What are the theoretical benefits of using the segment auction mechanism for ad allocation in LLM outputs compared to other approaches?
The theoretical benefits of using the segment auction mechanism for ad allocation in LLM outputs compared to other approaches lie in its ability to maximize a new notion of logarithmic social welfare, LSW, while ensuring dominant strategy incentive compatibility, DSIC, and individual rationality, IR. The segment auction optimizes the allocation of ads within each discourse segment, balancing economic efficiency and fairness in generating LLM outputs. The auction mechanism is designed to incorporate relevant ads into the output of LLMs using the Retrieval Augmented Generation (RAG) framework, enhancing the reliability and quality of the generated content. The segment auction ensures that advertisers are motivated to report their true willingness to pay for their ads to be shown, leading to optimal outcomes in terms of social welfare and revenue generation. Additionally, the segment auction allows for multiple ads to be allocated per segment, providing flexibility and coherence in integrating ads into the LLM outputs, ultimately leading to higher output quality as measured by the cosine similarity between embeddings of the output with and without ads. The theoretical analysis confirms that the segment auction is a randomization over truthful auctions, ensuring that advertisers are incentivized to participate truthfully and that the expected payment aligns with pricing rules derived from Meyerson's lemma. Overall, the segment auction mechanism offers a robust and efficient way to allocate ads in LLM outputs, optimizing both economic efficiency and user satisfaction.
How is the relevance measure computed and utilized in the auction mechanism for ad allocation?
The relevance measure in the auction mechanism for ad allocation is computed using a model from the Sentence Transformers library. This model maps input sentences or paragraphs into an embedding space where semantically similar texts have higher cosine similarity, while unrelated texts have lower cosine similarity. In the auction mechanism, the relevance measure is utilized to determine the relevance of each ad to the user query and the generated output. The relevance measure, denoted as Q_I, captures the relevance of each ad I to the query X. This relevance measure is then used in the allocation probabilities of the ads. Specifically, the relevance measure Q_I is multiplied by the bid B_I of each advertiser to adjust the selection probabilities of the ads. The relevance measure plays a crucial role in calibrating the selection probabilities based on the relevance of the ads to the user query, ensuring that more relevant ads have a higher chance of being selected for inclusion in the output. The relevance measure helps in optimizing the ad allocation process by incorporating the semantic relevance of the ads to the content being generated by the LLM, ultimately enhancing the quality and effectiveness of the ad placements within the output.
What results were achieved in the experiments comparing different auction scenarios for ad allocation in LLM output generation?
The experiments comparing different auction scenarios for ad allocation in LLM output generation yielded several key results. Firstly, the segment auction with replacement had the highest social welfare, followed by the one without replacement, due to differences in allocative efficiency among advertisers. The segment auction without replacement outperformed Naive 2 in terms of social welfare. However, the multi-allocation segment auction had the lowest revenue due to charging lower payments to winners based on multiple allocations at once. The relevance of the segment auction with replacement significantly exceeded that without replacement, particularly for the ad Bookhaven with high relevance. Naive 2 and the segment auction without replacement had similar overall relevance. In terms of minimum social welfare, the segment auction with replacement had the highest value, while the segment auction without replacement selected different ads for different slots, impacting the minimum social welfare. The output quality was highest for the multi-allocation segment auction, indicating that allowing flexibility in deciding which part of the document to incorporate ads led to better articulation without compromising output quality. The qualitative analysis showed that the multi-allocation segment auction produced a more coherent output by optimizing over the entire document to incorporate selected ads, unlike the single allocation segment auction which forced each ad into each segment, resulting in less cohesive output.
What are the limitations or challenges discussed in implementing the segment auctions for ad allocation in LLMs?
The limitations or challenges discussed in implementing the segment auctions for ad allocation in LLMs include the need to ensure that each segment is rich enough to capture click-through rate by itself, as well as the assumption that the advertiser's utility is additive over each segment. Another challenge is the computational complexity and query complexity associated with the relevance and the LLM module in the combinatorial segment auction, which requires computing individual relevance as well as set-wise relevance. Additionally, there is a challenge in calibrating the relevance measure with the actual click-through rate, center, in the combinatorial segment auction. Furthermore, there is a challenge in ensuring that the mechanism guarantees a non-negative probability of selection to every ad for every segment to optimize the logarithmic social welfare. Lastly, there is a challenge in designing the allocation and payment function in the multi-allocation segment auction to exhibit several desired properties while allocating multiple ads in a single segment.